If you want something to play with, go and find yourself.
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA, and I'm going to help you by going over some math concepts and examples. Good luck.
So for the third example, we have a differential equation describing population growth. So dn dt equals, and we're defining this as g of n. It equals n times 1 minus n over 50 minus 9n over 5 plus n. So to find the equilibria points, we're going to set this at g of n equal to 0. So we're setting n times 1 minus n over 50 minus 9n over 5 plus n equal to 0. And we can factor out an n from this whole expression, and that'll give us 1 minus n over 50 minus 9 over 5 plus n. So we can set this n equal to 0, and that gives us one equilibrium point. And if we set this equal to 0, we need to give everything a common denominator. So we'll multiply everything on the top and bottom by 5 over n. So 1 becomes 5 over n plus 5 over n. N over 50 times 5 over n plus over 5 over n minus 9 over 5 plus n. And this will give us 5 over n, or 5 plus n, minus n over 50 times 5 plus n minus 9, all over 5 plus n. So for this whole thing to be 0, the numerator must equal 0. So we set 5 plus n minus n over 50 times 5 plus n minus 9 equal to 0. And simplifying this, we get negative 4 plus n minus n over 50 times 5 minus n squared over 50. And then this becomes n over 10. So we get negative n squared over 50 minus 9/10 n minus 4. Oh, this should be plus 9/10 n. Now if we multiply both sides by negative 50, we will get 0 equals n squared minus 45n plus 2,000. And then factoring this, we get n minus 40 times n minus 5. So our two other equilibrium points are n equals 40, n equals 5, and we have n equals 0 from before. So now we're going to check the stability of these equilibria by differentiating g of n. And when we do that, we get n minus, we get 1 minus 2 over 50 n minus negative 9, and we're going to do the quotient rule, so 5 plus n times 1 minus n times 1 all over 5 plus n squared. And simplifying this, we get 1 minus n over 25 minus 45, because the n's will cancel, over 5 plus n squared. So now we plug in our equilibria. When we plug in 0, we get negative 4 over 5, which is less than 0. So this is a stable equilibrium. When we plug in 5, we get 0.45, which is greater than 0, so this is unstable. And when we plug in 40, we get 1 minus 8 fifths minus 1 over 45, which is greater than 0, so this is stable. Or sorry, which is less than 0, so this is stable.
Tell it like it is. My time is too expensive, and I'm not